It's probably the hottest it's been all year. Yeah, we've been kind of, I mean, except for the rain the last couple of weeks, it's been temperature-wise pretty nice this spring and summer. I think we had the coolest June in like 6 years. Yeah, we still haven't hit 100 degrees. Yeah.
Like heat index.
It's been uncharacteristically humid for Central Texas. It's kind of muggy, and the reservoirs are full, at least LCRA, like, and they're super happy about that.
Okay, so he is extremely intelligent. Just let him know.
We'll take what?
We'll take that way back.
Okay, all right, so we are allowed to do that, like, we're just not prepared to get into, okay. Okay.
It's 5:36. Like to call to order the meetings of Marion County by the numbers 46, 47, 60, and 67. Fund 7 will not have an official meeting, but members of Fund 7 are here. Is there any comments from the public before we get started? All right. So this meeting is been set up in order for us to hear the consultants who worked on the dam evaluation to give us that presentation. Afterwards, there is a consider an act on item as you can see on the agenda, and that's more business related. But Ed can explain that once we're done. With that, Schnabel Engineers is the engineering firm that worked on this project. With us tonight, we have Jeremy Young, a professional engineer, and Jimmy Crowder also. And so with that, I will hand it off to you.
All right. Thank you. Folks hear me okay? All right, good. Excellent. Thanks again for inviting me here. Happy to be here to talk about the Bear Branch Dam spillway cement repairs and service spillway replacement project. Again, my name is Jeremy Young. I'm with Schnabel Engineering. Oh. All right, sorry about that. Just a real brief intro on myself and another colleague I brought here with me today to help field some of the Q&A. I'm a civil engineer by training, excuse me. Been with Schnabel for 25 years. Most all of my experience has been with dams, spillways, and reservoirs. A lot of that is with the inspection, evaluation, and rehabilitation design of existing dams and spillways. I currently lead up Schnabel's dam engineering practice here in the state of Texas. And I am the project manager and also the engineer of record for the Bear Branch Dam project that we're going to talk about this evening. And with me, I brought Jimmy Crowder. If you just want to give a real brief intro of yourself.
I'm Jimmy Crowder. Been with Schnabel for years now. And all that focused on the dams and reservoirs. A lot of work on concrete spillways, so I'm really familiar with the situation here and elsewhere. And recently, in the last 5 or 6 years, I've been doing a lot of work in Texas. I'm stationed in Georgia. But I'm also in Georgia, but I'm out here in Texas.
And I'm coming out of Austin, Texas. Maybe I'll just have you do it. Next slide, please. Excellent. All right. So over the next, I don't know, half hour or so, we'll see how fast we can get through this, or as much time as we need to spend to answer all your questions. But we'll start by reviewing just some general site features at the project, going over some just general dam engineering terminology, just to get you all up to speed. Also give a brief background on the project and why we're here. Talk about the preliminary engineering study that we conducted through 2024 and what those excellent. Talk about what our findings and our recommendations were for the preliminary engineering study, and then really get into some of the supporting evidence to back up why we recommend it, what we recommend it. And then we'll open it up to you all with a Q&A or a discussion. So the Bear Branch Dam, when we talk about the dam, that's going to include the entire site, both the spillway, let's see here, which is here in the center of the dam, also the earthen embankments on either side. When we talk about left or right, we're assuming that one is looking downstream. So in this case, water is flowing up the page, so we're looking downstream. So the right embankment is on the right side of the page. The left embankment is on the left side of the page. The spillway itself is comprised of two main features. You got the service spillway, which is a lower notch in the central portion of the spillway. That's going to pass, your normal base flows and some smaller flood flows. And then at some level, the auxiliary spillway, which is on either side of the service spillway, is going to activate and be able to pass your entire design flood. So that's the site layout and some basic terminology. Some other statistics that I think are worthwhile to bring up here. The dam itself, it's an earthen embankment dam. It's about 27.5 feet high. Its reservoir storage, the amount of water that it can store at top of dam, is just over 5,600 acre feet. And TCEQ, who regulates dams in the state of Texas, has different criteria for classifying dams. One is a size category, and they can categorize dams either small, intermediate, or high based on the larger of the storage volume or the height. And seeing that Bear Branch Dam stores over 1,000 acre feet, but less than 50,000 acre feet, it's categorized as an intermediate size dam. In addition to size classification, TCEQ also classifies dams in terms of their hazard potential. So the hazard potential, it's an important characteristic. It's not necessarily classifying or characterizing a dam in terms of its current condition, but rather what would the impacts be downstream in the event that the dam would fail, a potential failure. So it's important to note for Bear Branch Dam, there's a lot of downstream development. So in the event that this would fail, it's been estimated that more than 7 lives or 3 habitable structures would be impacted downstream, with significant economic loss downstream of the dam as well. Therefore, it's characterized as a high hazard potential dam. And these two items, size classification and hazard classification, together kind of dictate what the dam owner needs to do in terms of compliance with TCEQ criteria. For instance, how many times a year or how often they need to inspect it, different design criteria in terms of spillway design, floods, or other engineering analyses that need to be performed to keep the dam in compliance. So as a high hazard dam, TCEQ's requirements are going to be very stringent. Thank you. So in terms of hazard potential downstream, what's at risk? Why is this so important to us? I mentioned there's a lot of downstream development below the dam. And if you're not familiar with the area, I have a screen cap here of, laser's not working. This is a screen cap of an inundation map that is included in the emergency action plan. And it's just a snippet, but here on the left side of the screen is where the dam's located. This yellow line represents the inundation limits in the event that the dam would fail. And you can see, there's a lot of neighborhoods and developments downstream. All of these would be impacted in the event of a failure. And this is just immediately downstream of the dam. The inundation limit flows another 14 or 15 miles downstream before it's terminated. So I mentioned there's a lot of residential structures that are at risk. Also, 7 roads would be overtopped in the event that this dam would fail, including Quickendale Road, immediately downstream of the dam, would be overtopped by almost 5 feet. The depth of water at that location immediately downstream of the dam would be over 23 feet high, just immediately downstream of the dam in the event that it would burst. And then as that flood wave propagates downstream, Lake Woodlands Dam, would also be overtopped. So the volume of water that's in Bear Branch would flow all the way downstream, fill up the reservoir at Lake Woodlands to a point that dam would overtop by over 3.5 feet, and then would cause that dam to fail as well. So we would call that a cascading dam failure. So it's a very significant, catastrophic, damaging series of events where you have one dam fail after another. So a lot's at risk here. That's why this project's important to all of us, or me, Schnabel, SJRA, and should be important to all you all. Next slide, please. So for some project background, there's been several inspections and evaluations, investigations at the dam site, particularly at the existing spillway over the last couple of years by previous consultants. They recommended, based on their observations, that there were structural deficiencies with the spillway, primarily with the existing service spillway, and they recommended that SJRA replace the service spillway. And that recommendation served as the basis for SJRA selecting Schnabel to move forward with a preliminary engineering study. Next slide, please. So the scope of our preliminary engineering study is here listed on the screen here. One of our initial tasks were to review available project documentation. Schnabel needed to get up to speed on the project, the history, the performance, the design, and so on and so forth. So we did a pretty detailed review of the data that was made available to us. Also, as one of our early activities, we performed a site reconnaissance to get our engineering team out on site to observe site conditions as they are in the present day. In this case, it was 2024, and just get the lay of the land. As part of that site reconnaissance, we also performed a televised video inspection of the outlet conduit, which had not been performed in some time. And we had a subconsultant work for us that provided a topographic and bathymetric study of the dam site and an underwater area just immediately upstream of the reservoir. And that would help facilitate our evaluation of alternatives and potentially a future design. We also updated the hydraulic and hydrologic analysis. That too would also serve as the basis for us performing an evaluation of spillway alternatives. And then we compiled all that information, summarized our results, our recommendations into a preliminary engineering report. That report, signed and sealed, was submitted at the end of last year. And then through the first half of this year, we've been working closely with SJRA to address some of their comments, evaluate some additional alternatives, refine some cost estimates, also perform some coordination with the Army Corps of Engineers, who's providing some funding to this project, and then also prepare for this meeting that we're here this evening. And then a future task that we have will be to perform some preliminary permitting coordination with the Army Corps of Engineers and TCEQ once we get into, or once SJRA and other stakeholders decide on a preferred alternative to move forward into detailed design. So that'll be a future task. Next slide. So in general, the findings and recommendations, some good news. The spillway and the dam have adequate hydraulic capacity to pass the spillway design flood that's required by TCEQ. And that storm is represented in terms of a percentage of the PMF, or the probable maximum flood. So for this project, the dam is required, or TCEQ requires that the dam pass 78% of the PMF. And we define the PMF as, it's a hypothetical flood event, and it's going to represent the most severe combination of critical meteorological and hydrologic conditions that are considered reasonable for this specific area. In layman's term, it might be like a Noah's Ark type flood. It's a very extreme event. For this project, we're estimating that it's about 35 inches of rainfall over a 24-hour duration. So for comparison, the 100-year rainfall that we obtained from NOAA Atlas 14 rainfall data for a 24-hour duration is about 16.5 inches. And then for comparison, for some locals, the 2016 tax day flood was estimated to be about 12 to 16 inches over a 12-hour duration. So what I want to emphasize here is that the design storm, while it's very extreme, the service spillway, the auxiliary spillway, the dam itself has not been subjected to the design loading thus far, just a fraction of that. So moving on to our findings and recommendations, the evaluation of alternatives that we performed was initially focused just on replacing the existing service spillway. So we evaluated 3 different configurations for those alternatives. I'll show you some slides here in a second. We developed some opinions of probable construction costs or cost estimates for each one of those alternatives. You can see that the prices or the costs just for construction in today's dollars ranged from $5 million to about $5.7 million, depending on the alternative. However, the condition of that auxiliary spillway was very concerning from Schnabel's point of view with regard to how it was designed, how it was constructed, and a performance perspective. And this is something that we noted to SJRA very early on in the project. In fact, even when we were interviewing and competing for the project, just based on a very cursory review. But then as we went through the rest of the analysis and dug into the details through that project review and other observations, we were still very concerned with the condition of the auxiliary spillway. A lot of the issues that were noted previously, and ones that I'll get into here in a little bit, they exist not only just for the service spillway, but also for the auxiliary spillway. So Schnabel was recommending, or is recommending, that SJRA move forward with a more comprehensive approach to rehabilitate not just the service spillway, but the entire spillway, including the auxiliary spillway. Next slide, please. So these next few slides here, I just have some very schematic drawings of the alternatives that we looked at. This is alternative 1. The existing service spillway used to be located here. This would be abandoned, backfilled, capped with concrete, and the replacement spillway would be offset one side or the other, doesn't really matter. In this case, we showed it to the right. It would be constructed more or less in kind. However, we have vertical sidewalls here to help with ease of construction. Slide. The second spillway alternative, a little different than the first, where we would construct the existing, or we would construct the replacement service spillway within the footprint of the existing spillway. This would complicate construction a little bit, hence that's why construction costs for this option are a little more expensive than the other two. Next slide. And then the third option, which is more or less a refinement or a slight variation of the first option, where we have the replacement spillway offset from the location of the existing. However, the construction sequence and the method in which we would excavate through the dam to construct this would be slightly different, a little more complicated, a little more costly. So this option is sort of in the middle between the first two in terms of complexity and cost. Next slide. So over the next few slides, I'll get into some of the, I'll call it supporting evidence, or some of the rationale that we had on why we are recommending to not just replace the service spillway, but also replace the auxiliary spillway. So the first bucket of issues I have are, I'm going to call design and construction issues. So I have shown on the screen here snapshots of the as-built construction drawings from 1983. And probably can't see all the details from where you're sitting, but as we're going through it in very detailed engineering analysis, the one thing that stood out to us is that the slab that's constructed over the embankment, which is going to serve as your armoring for your spillway, is relatively thin. It's only 8 inches thick. These slabs need to be designed and constructed in a way that it has enough weight, enough resistance to resist uplift acting underneath the slab to prevent flotation or hydraulic jacking. 8 inches is not enough. Most times we see slabs on the order of 15 to 18 inches. So the slab is very thin and it's not going to resist uplift in the event that seepage enters through open joints and works its way underneath the slab. So how does water get underneath the slab? It's going to be through joints. So the other concern that we had with regard to the design of the structure is the joint details. They do not contain, or they do not include water stops, cutoff walls, dowels, continuous reinforcement, and other features that are going to prevent water from infiltrating into the joint and also keeping those joints tight. So as we know, and I'll get into some of the history of the performance, these joints have opened up. They've allowed water to come under the spillway and erode material. So a more modern design would include a thicker slab to resist uplift and these other features here to prevent water from infiltrating these joints. I'll note that the primary seepage control device in these joints at this spillway is just simply joint sealant applied at the top of the joint, which I'll get into more of the performance issues. But that is not a long-term, robust, reliable means to prevent water from infiltrating through these joints. It becomes a maintenance issue, and it's something that owners need to repair or replace periodically. And you'll see that that's just the case here. Next slide, please. So this is a screen cap of just one federal agency, U.S. Bureau of Reclamation, that is involved with the design and construction of hundreds or thousands of dams nationwide. And in their design guide, they have recommendations or requirements actually for their federal projects on how joints are to be constructed. So this is what a more modern joint would look like. You see, this is a cutoff wall. This would lengthen the seepage path as water is flowing beneath the spillway. It would have some drainage material, the drainage pipe, to collect any seepage, relieve any uplift that might be developing below the spillway. We talked about dowels through the joint. That's going to hold the joints together. And then also PVC water stop. And that's going to be the primary seepage control measure through the joints. So all these measures here are going to keep that joint nice and tight and closed and prevent water from infiltrating and subjecting the slab to excessive uplift pressures. And again, to get all of these items in here and to get adequate cover, concrete cover between these elements, this slab is probably going to be at least 15 to 18 inches thick. And at Bear Branch, we have 8 inches. This is a joint with water flowing down the page. So we would call this a transverse joint. We have a longitudinal joint, water's flowing into the page. Joints are somewhat similar, but without a cutoff. We have a dowel bar, reinforcing steel, and so on. So just want to show you what the standard of practice is for today's standards to design these joints. Next slide. Another issue that we had with, or that we found with the original design. So I don't want to spend a whole lot of time on the embankment, and but this is a cross section through the embankment. Water would be on the left side of the page, and on the downstream slope, we have what's called a blanket drain and a toe drain. So that's going to control seepage and collect seepage through the embankment. For materials like we have here at Bear Branch, the drainage material would typically, or would be, some sort of fine sand, like a concrete sand. In this case, it's a very coarse aggregate, almost like a pea gravel. So that's a concern, because we look at dam filters and drains in what we call filter compatibility. The materials need to be compatible with one another. We need to prevent seepage as it's working its way through one medium into another, we don't want it to carry fines with it. So you can imagine if it was an open graded stone with a lot of pore space, it's going to be able to take material out of the embankment and into that stone material. So you're going to be left with voids in the embankment and a clogged drain, which is going to render it useless. Now, in terms of the spillway, what we're concerned with is that this embankment abuts immediately adjacent to the spillway. So this coarse drain material runs right along the face of the spillway. So now there's a potential for material that's migrating from the embankment or from the foundation and into the spillway drainage material, and also beneath the spillway itself, maybe out, and I'll show you a little bit of evidence of potential migration of soil out of either below the spillway or out of the embankment into the stilling basin. Next slide, please. Moving into construction-related issues. I think in general, the photos that we had from construction in 82, 83 generally showed poor construction techniques. The few reports that we had from construction were site visits by the engineer at the time, right after precipitation events. Seemed to be a very rainy season during construction of this facility. And you may not be able to see it from where you're sitting. Maybe for folks that printed out some of the PowerPoints, you can see it on the printed, but these photos were taken right after a precipitation event, and the subgrades, the material underneath the rebar cage that the concrete would be placed on, seems to be disturbed, damaged. There seems to be some erosion rills, maybe some soft, slimy, mucky material that ordinarily these cages would be pulled off, that material scraped, cleaned off, and get down to a nice sound subgrade. But there's no evidence that that was done. So this disturbed subgrade material seems to be left in place, which would have been a wet, soft zone immediately below the spillway that's easily erodible, and potentially could lead to some settlement of the spillway itself. So overall, we just felt that the spillway construction was relatively poor. Next slide, please. All right, moving into some performance-related issues. This is a photo looking upstream at the auxiliary spillway during our site visit in 2024. You can see there's 2 wet spots in 2 of these joints running along the spillway, and a close-up here on the right-hand side of the screen. Just further substantiates that these joints are open and can allow water to flow through, possibly material to flow through, or in the event of high flows, there could be enough pressure on top of the slab where it could allow water to work its way underneath the slab. Next slide, please. So this particular issue has been noted. This is a photo that I found from 1983, just after the project was completed, and they've been noting this seepage condition in this very location since 1983. So this has been an ongoing issue for quite some time. Slide. So I talked about filter compatibility and drains and migration of material. When we were out there in 2024, we noticed a lot of sediment in the stilling basin. Some of that can be attributed to erosion, just downstream, but given the evidence of voids below the slab, poor filter compatibility, and other issues, we suspect that this material is also being migrated from the embankment or below the spillway itself. Next slide. And again, this issue has been observed since, this is a photo in 1983, where you have a lot of sediment in the same location. And let's see, this is a photo from a inspection in 2021, more recently. So a lot of sediment in the stilling basin is generally not a good sign. It's coming from somewhere, and it's an issue that needs to be dealt with. In fact, the engineer who observed that, I think, said just that this is an issue that could be a more significant issue that needs to be addressed immediately. And 40 years later, or 50 years later, it's still occurring. Next slide. Another issue I mentioned, with the potential of fines migrating out of the embankment, out of the foundation, below the spillway and out, there could be voids here, and those slabs could settle. During our inspection in 2024, it was a dry period of year. It hadn't rained for several weeks. However, there was water ponding in the left and right sides of the spillway. So those areas appeared to have settled. There was a survey performed, I want to say 2019, 2020 or so, where the surveyor did pick up that the slabs in these areas have settled a few tenths, where the middle of the spillway is not. So just further more evidence that there's potential voids below the slab and things are settling. Next slide, please. Just some shots from the as-built constructed spillway in 1983. As you can see, the spillway was intended for this stilling basin to be constructed level and flat. And here there is, negligible water ponding compared to, can we go back to the previous slide? You can see now we got, up to several inches of water ponding in there. So some pretty significant settlement over the last few decades. Next slide. And next slide. So let's go into some performance-related issues. Just want to note that SJRA assumed responsibility of the dam in the late 90s. Since then, they've embarked on at least 2 repair efforts to address the joint sealant between late 90s and 2013, when I start my timeline. So they've been a pretty proactive owner and have been repeatedly addressing the joint sealant issue over time. In 2013, 2014, there was an effort to grout open spillway joints in a joint near the service spillway and the auxiliary spillway. The joints were also recaulked, and concrete spalls or damages at those joints were also repaired. And then just 7 years later, 2 other voids were identified at that same joint location. The contractor pumped 6 to 9 cubic yards. It's basically like a concrete truck worth of grout below the spillway. So pretty significant volume, right? However, what they noted was that the grout exited open voids, or sorry, open joints. Again, further substantiating that the joints here are open and material is able to flow in and out. And they also noted that the grouting program was relatively unsuccessful. So despite pumping all that grout, there were still voids up to 2.5 feet below the spillway. Later in 21 and 22, there was an investigation performed. Voids were found up to 1/2 inch deep in 2 different core locations, and one particular area that was about 36 feet square, voids of 6 to 8 inches were found. So in response to that, additional repairs were performed in 2022. You're starting to see a pattern here. And the spillway repairs included resealing the joints, patching the concrete, grouting voids, and also sealing cracks. And then by the time that we got it there, Schnabel in 24, we've noted that some of those concrete patches have started to delaminate, and some of the joint sealant that was just applied only 2 years prior has already started to peel off. Next slide, please. So in conclusion, this is just a snapshot from, or actually a quote from our report and possibly our memo that we submitted last week. But essentially, Schnabel's of the opinion that significant dam safety issues do exist at the dam. And if left addressed, they're going to result in continued deterioration of the spillway and leading to a progressive failure of the spillway and an uncontrolled release of the reservoir. So we're recommending that a more comprehensive approach be taken to both the service spillway and the auxiliary spillway, and that SJRA embark on that immediately. And again, I just want to key on that, rehabilitating only the service spillway is not going to address similar issues that also exist with the auxiliary spillway. However, we understand funding and timing is always difficult. So we just want to note that, if for some reason construction needs to be prolonged more than maybe 5 years, that SJRA continue implementing these interim risk reduction measures. Next slide. So I guess the last thing we'll close on is project costs. And I want to hand this over to Ed Shackelford with SJRA.
Thanks, Barry. Before I get into the numbers, I do want to mention some of our staff that are with us tonight. Tommy Curtis, who you all have seen before. Brett Rayleigh, our raw water enterprise manager, who was previously our Lake Conroe division manager, and he stepped up to a new role, but it still includes supervision, oversight of the Bear Branch group. Dan Hildebrand, our engineering manager, and then Greg Lushbaum, who has been the project manager on this project, along with the Bear Panther project. So you can see if you'll take a look at the bottom line number, phase 1, which you've authorized, is the service spillway plus the soil cement replacement. So that's that first piece of phase 1 at 6.85 million. Originally, that was estimated about 5.2, and that was right after COVID, but before a lot of the concrete and project escalation that we've seen. Phase 2, which is what Jeremy has been talking about this evening, of replacing the auxiliary spillway, is another $7.15 million. So a total of 14 million. What I want to emphasize or go over with you all is we've received 3.6 million from the Corps of Engineers. That was authorized about 2 years ago. Congressman Crenshaw was able to get that allocated. He's put another 5 million in a new appropriation that will be considered by Congress by the end of this year. And if approved, we would have those funds March or April of next year. So that brings a total of 8.6 million from the feds. They take 10% out of that 8.6 for project administration on their side. So we're working with $7.74 million from the Corps to assist in project funding. So that leaves roughly 6.26 million that needs to be covered by local match. Now, there has been some funds from the MUDs as part of this phase one, and trying to remember the exact amount, but there's probably close to $900,000 between the 5 MUDs that have contributed. So somewhere we've got to make up, if you all decide that you want to move forward with phase two, add this into the project, then there's some local funds that need to be added into the total project. So those funds range depending on a couple of ways to approach it. If you contribute cash for engineering and then use bonds for the balance of the local funds, that number is roughly about $5.5 million worth of local funds that are still needed. If you sell bonds and want to be reimbursed for the engineering funds that have been contributed, that's roughly $7.2 million. So here are the questions to be considered. Proceed to include phase two. Remember, the funds won't be fully available till sometime next year, but we still have design engineering to do, which can be covered with the local funds that have been provided. If you decide you want to cash fund it, then obviously we would put together a schedule. All the funds for construction would need to be available sometime in late 26, maybe early 2027. So that makes it a pretty heavy cash call for FY27 budget if you cash fund. If you do bonds, then of course that spreads it out over a little bit longer period. You can look at 10-year bonds, 15-year bonds, 20-year bonds. I want you to know SRA we don't care whether you want a cash fund or bond sale, okay? If we do bonds though, we've got to do the supplemental agreements like what we did on the 2017 sewer project. So we would have time to do that if that's the direction you want to go. Let's see. One thing to think about, if you say no to phase two, and if you remember, you all authorized Eric to sign a letter of support for us to pursue the $5 million with Congressman Crenshaw. If you say no to phase two, those $5 million do not come to the MUDs. Congressman Crenshaw will reallocate those funds to another project. So that's something to keep in mind. So that, I think we're ready for questions. David. Hang on just 1 second. Well,
you know, if you look around this room, a lot of it has been here. So a lot of us don't understand probably how this structure, your branch, it's called support structure, was created. So if I listen to the engineer, he's talking about dam area that cascades down, like Willis Dam, cascade forward. I even look at this and say, you know, we have 5 months here today. It shouldn't get 8%. Because the problem goes far beyond maintaining the dam structure. We're talking about how to rebuild the structure. And then, you know, some of the months we want here have been busy managing projects on the east side of Lake Willis and north of, you know, on the Eagle Forest, which drains into their branch. So, you know, I begin to wonder whether the structure of this heating is correct in basic life. I really those that question the area in that discussion, but when they just make that day, if that Lake Willis, to break that dam, it's going to be the way, you know, that's That's a much bigger issue.
I can tell you what it's based on currently, and then I may have to call on Jim or Eric to help me. But there's a certain drainage area in the 5 muds that pay the maintenance, that fund the maintenance of Bear Branch, the dam and the service area on Bear, Panther, and Alden Branch. And each mud has a different pro rata share based on SFDUEs that for the area that drains to Bear Branch or Panther or Alden.
And I understood that.
Okay.
Because
And I don't have the percentages memorized by,
I'm wondering. Correct. Basically, the dam. And it breaks, it affects Farm 9. And if you equal drain into there. In effect, like Lucas too.
Okay.
Question I didn't
That-
discuss at the bottom.
that sounds like a policy decision.
I can speak loud enough. I was just curious, Louis Crenshaw's office, what kind of, commitment do we have from them? Lottery, yeah.
Well, right now, the 5 million is in a environment and water bill of piece of legislation. So the 5 million is in there for this, and it's earmarked for this project. It all depends on Congress approving the budget at the end of the year. Now, so far, up till now, they have. I can't guarantee that the budget will be approved.
What happens if
Then if you decide to go forward with phase 2, the rest of the cost is borne locally. Fred?
There's a couple of basic questions that haven't involved all of this. Some of it's had a bigger, some of it's had about observations made by Carolyn.
Okay.
First and foremost, what have we learned from examining the work that we've done 40+ years ago? And going forward, are we not to repeat the same mistakes again? That's clear. But has there been any new technology? Has there been a different oversight? Clearly, this was over before you joined the organization. And
Many years.
in fact, probably most, in fact, funny that was even more than that. But the fact
I was.
is, we're here.
Yes.
And we're looking forward. So the question is, first, what have we learned from the failures that have been identified? And what steps are we taking? And what's the ultimate specific recommendation that they're giving us? Is it just 14 billion or is it more?
Well, right now it's based, all this is conceptual, as you know, from what you've seen. There are no design drawings. So specifics, quantities, steel, amount of concrete, the amount of dirt work, all that's been high level estimated. We won't have exact numbers until we get into preliminary design. Confidence level, Jeremy? You might as well stand right there.
Yeah. In our cost estimate, if you have a copy of our preliminary engineering report, I believe it presents a level of accuracy of -50 to +100% at this stage. And yeah, just, there's a lot of unknowns at this point in terms of when it's going to be bid.
We need to move forward to get one next step. This is why. Does science have any impact on any of the structures that are involved in this repair?
Buttons.
And then we grow more from our water supply from the aquifer. It will only increase over time, decades. But we're dealing with this over decades. So the question I've got is, what is the science after that? And then after that question, be my last one, is I'd like to get a risk assessment analysis based on what you researched, and I got specifics toward that. So if it's risk of science first, go to the last question I've got.
So maybe Jimmy can confirm, but I think when we talk about subsidence, I'm thinking it's the same settlement. And is that what we're talking about, the settlement of the structure?
That is correct.
We have evidence that it has settled. And we have surveys that were performed just a few years ago. And you can see with the water ponding in the ceiling piece on either side that there's been some settlement there.
And there are steps that you can take to mitigate that. That's a question.
Depending on what the issue is, Jimmy, do you get it?
Which we only learned when we did more research.
Or geotechnical work.
On risk assessment, given the notion of cascade failures of the dams and reservoirs, I'm a graphic guy, and there are chart graphs that can be, terms that can be created showing what the risk assessment is for failure and what the probability is and what the cost is to mitigate or repair or replace those different aspects. Is that something that you can provide, or is that something that the SBRA can provide for us? All of our board members.
At a very high level, like I guess I would call it a qualitative risk assessment. It's kind of baked into the analysis that we performed here as part of the preliminary engineering study. And then I mentioned that there was a coordination with the Corps here earlier this year, and we've talked about performing a more detailed risk analysis, maybe towards what we would say a semi-quantitative or semi-qualitative risk analysis with SJRA to help estimate probabilities in terms of order of magnitude and also estimate consequences in terms of order of magnitude. And there's different federal agencies that have methods that we could follow and also risk matrices to depict or illustrate the risk on a graphic to help us communicate what the risk is to all of you. And if it were to exceed tolerable risk guidelines and help inform us on how urgent of an issue that is. But like I said, like we've done that very qualitatively here, and we're convinced it's a risk driver.
You pretty perform more detailed risk assessments a lot. We do that all the time, especially for hydropower clients that are regulated by Federal Energy Regulatory Commission. Working with Lake Livingston here in Texas, one of those right now.
Your comment is very interesting thought. In your 25 plus years experience, other municipalities that have entered into insurance contracts to back up to possible issue to face our geography. Has anyone ever, any municipality ever created an insurance model for this type of failure, or is that all? It's never been done.
So I've seen a couple of examples where they had insurance policies. There was one in Florida and they ended up not paying. So it was with all policies and exclusions. This one, they were able to, really the problem was from the original design. That was excluded policy. But you don't see a lot of in our work at all.
I think that if there's any people and costs to our constituents, we need to come up with a comprehensive plan that may or may not include insurance to protect not only residents would be affected, but also commercial properties and retailers. Because that's what we're all about. So folks that live here and folks that work here. I'll turn the microphone to somebody else who might have more specific.
Fred, to go back to your question, when we first started talking, probably about a year and a half ago, there at the River Authority, we visited with our risk pool insurance provider to find out if they did carry dam insurance, and they do not. Probably because of the liability of it, but that cost, if we were able to find such a policy, that cost would be built into our budget, which you all would pay.
knowing that just with the national coverage of the Fair Valley County failures, that they would be more, I think, responsive to being that proactive by the FCRA. But it's speculating. I think something needs to be done.
The other thing, we did investigate, going back to the risk assessment. Corps of Engineers was willing to provide a risk assessment for just short of $250,000, but it was not a structural risk assessment. And so we did not go that route, mainly because they would be basically looking at the PMF that Jeremy talked about. They'd be looking at our dam breach analysis, which has been done and is not that old. So they'd basically be taking our information and creating this analysis for $250,000. And it just didn't seem like a prudent expense. John, I think you have the mic.
Thank you. Nice summary presentation. All your documents. Your explanation helped. I'm wondering if you could just help me a little bit more by going back to your cross sections. There's 3 different pages in a row. I was hoping you could do a little more detail because I had a bit of trouble understanding what I was putting in.
This one?
That one.
There's 2 different, there's 2 before that. All 3 of them had.
Go back to the beginning.
Okay.
That one.
Could you just say a little bit more about what I'm looking at here with the different lines?
Sure.
I was cross sectioned. Other than that, I had a hard time understanding.
Yes.
Sorry about that. It's okay.
So this is a cross section through the dam. So we have water here on the left. This lower stage is the surface spillway. There's a concrete lined surface spillway at a lower elevation, and then superimposed behind it is a profile of the auxiliary spillway. So could we go back one more slide? Actually, back a few more. I don't know. There, keep going to the beginning.
Going towards the end.
Yeah.
Go back towards the beginning.
Yeah. Yeah, so we got the lower section is a section through the service spillway, and then superimposed behind it is a cross section through the upper section. So let's go back to that cross section again. One more. Yeah. So service spillway, slab, and stilling basin, and then at a higher elevation, you got the auxiliary spillway, slope, and then the
And the upper one, the embankment.
yes, and also the sidewalls. So that would be, that's the embankment, that's the earth component that's actually behind this sidewall. So let's go forward a couple slides. Yeah, so we got the embankment. I mentioned it's considered an embankment dam. In this case, it's a zoned embankment dam. So you have a clay core constructed through the center portion of the dam. So that's your primary water retaining feature. It's a cross section through the embankment. And then you got zones 2 and 3, which are going to be more granular, probably random material that's really just used to protect the clay core and also provide gentle slopes to lengthen seepage paths, make this more manageable from operation of mowing and that sort of thing.
Talking about that it should be fine sand is actually under the embankment.
Yes. Yeah, that's a blanket drain. So it's placed along the foundation, up against the clay core, that zone 1, and below zone 3, which is your downstream shell material.
Here's the control. Yeah.
Okay.
Are those the joints?
Yeah, so those are the joints. All right.
I think I understand the joints are the slabs, the way the slabs are connected
Yeah, exactly.
on the face. Right?
There's a,
And this
there's a
sort of-
figure all the way at the end. Could we go to that? Yeah, just scroll up through there. Yeah. Keep going, keep going. Yeah, this one right here. Double click on it. Okay. I got a figure that I think will help orient where all these joints are. No. One more. One more. There we go. Okay. So this is a plan view of the spillway. It's oriented in a little different direction than most of the other figures. We got flow coming down the page. So we got our service spillway through here. It's V-shaped or trapezoidal in shape. So it's flat bottom and then it slopes up to your auxiliary spillway slabs. And all these red lines here are joints. And it's just like the gentleman said, it's how those joints were constructed and how they abut into one another. So we have some transverse joints that run across flow, transverse, and then we have some longitudinal joints that run along the direction of flow. The dashed lines are actually where cracks have formed because the slabs were not constructed with the joints close enough to prevent cracking. So now we have all these joints here that have also been sealed and also present a maintenance issue where the joint sealant peels off over time and you need to repair that. So there are a number of joints that were constructed through the spillway that we consider to be suspect or have defect joint details, and then also a number of cracks that have opened up that are also vulnerabilities and defects in the slab. So apologize for not spending a little bit more time on those details.
Those plans, can you show me where the low water flow valve you want to fix this?
There's a intake over here that's submerged, and then there's, I forget the size, maybe 12-inch ductile iron that runs kind of in this direction. There's a valve box just upstream of the spillway, and then it makes a jog along the, let's see, this is the left spillway sidewall looking downstream. It's the right-hand side of the page because we got things reversed. And then it turns and it outlets through this sidewall here. So it's running along this side of the spillway.
Help a lot. Thank you very much.
Yes.
Question, you gave us 3 alternatives in your write-up. Sounded to me like alternative one, that's the least expensive one, was we were favoring in terms of operational as well, but that's the case. Please let me know how you feel about those 3 alternatives in terms of operation.
Operationally, I believe they're all equal. I think the difference is the manner in which they would be constructed. Yeah, so during construction, we talk about risk. We can reduce risk during construction by completely draining the reservoir for 12 to 18 months or whatever it's going to cost, or whatever it's going to take for during construction. That's going to give us more storage during construction, right? So when a storm comes up, it can fill and not activate the spillway while we're trying to work in it. However, there's probably a lot of mitigating factors where draining it's not going to be practical or possible from all the various stakeholders. So what we would need is a series of cofferdams or temporary dams in front of our areas of work to protect us from when a storm does come in. We're not going to get flooded and the work's not going to get damaged or potentially fail to dam. So the way we would preferred manner is we have an existing spillway here through the center of the dam, right? And we want to replace this. So why not divert water during construction through this and construct a new spillway off to the side that might be protected with a cofferdam? So that was option 1 and 3. We would divert flow through here during phase 1, protect this area with a cofferdam, and construct the new spillway. Then phase 2, we would cofferdam this area off now divert through the new spillway, and then decommission this and do our work over on this side. Option two, because we had the spillway, the replacement spillway within the footprint of the existing spillway, now we no longer have the advantage of being able to divert flow during construction through that auxiliary spillway. So we need a series of pumps and siphons and other diversions, which are going to be a lot more costly. So that's kind of the difference there. Does that answer your question, sir? Yes. So the difference between 1 and 3 is the manner in which the replacement spillway that's going to be offset would be constructed. For option 1, we assumed that this area would be protected with a cofferdam, and we would have essentially an open cut excavation through the embankment where the side slopes would be laid back, let's say 2-to-1 or 3-to-1. So the excavation would be rather large. To reduce the impact, so to speak, to the existing auxiliary spillway, option 3, what we had was a supportive excavation system. We would drive sheeting upstream, downstream through the spillway, and we would have vertical excavation sidewalls that would be supported like sheet pile and tiebacks and soldier piles and those sorts of things. So we would limit the amount of excavation, but it would have more complex, challenging construction with driving sheeting and other structural elements, but it would reduce the footprint of the project itself. So that's the difference between options 1 and 3. I mean, it's really a decision by SJRA. I think if you're looking at costs and ease of construction, I'd say option 1. I'm sorry, I think I heard, I couldn't hear.
If you could go back to slide 5, I'd appreciate it.
I like the thing.
Excuse me.
No, forward. One that's just line. Yeah. Why is that yellow line?
This yellow line represents the limits of floodwaters in the event that this dam would fail during the design storm. The design storm, the 78% of the PMF.
Did you model also the 100-year flood and the 500-year flood? Because what I'm interested in is knowing the percentage breakdowns of economic loss by infrastructure type.
Schnabel is not. This was an analysis performed by another consultant to support development of the emergency action plan. So from what I know in that report, they modeled a sunny day breach. If the dam were to fail on a sunny day with dry weather, or the full design storm. I'm not aware that any interim storm events were modeled like you suggested.
How wide it would go, because that's pretty wide swath. Right.
Eric?
The LA do 100-year, 500-year model in the fair bank project.
Well, they did the tax day with their party.
Do we have an overlay of the state flood and Harvey and the Memorial Day floods?
We do not, but my understanding is this is worse than most.
Well, obviously, that's the thing of breaking on Sunday, but I would like to see that because I know there's a lot of golf courses and that's, I mean, I'm not trying to make light of what happened in the whole country, but I am interested if 100-year flood, there were only X number of FEMA claims. And yes, those things are very real. worked on FEMA plans most in Cruz's office. But I'm interested to see what the overlay is with this floods.
Let me see if there's a way we can do that. That's not in their current scope. You, believe you had a question?
Yeah, a good presentation and his pretty good question as well. Kind of related to the breach, is that a complete catastrophic loss? All of the water behind that dam goes downstream. That's what we're modeling.
Yeah, that's right.
I use the pictures of that. That was all that water, the whole spillway was washed. Is that what you're saying?
We don't have a photo of a dam breach in action illustrating the release of water, but we have some photos in the back of the slide of spillways that were constructed similarly to Bear Branch that suffered damage. But Jimmy, it's not during the breach, right? But I mean, the breach opening, I forget, it would be full height, 20 foot high, 27 foot high. And I think it's like maybe it's as wide as 3 times the height. So maybe another 75, 80 feet wide hole through the dam that's allowing the water to release. And I think I haven't gone through the previous consultant's analysis, but ordinarily it would take half an hour or an hour for that breach to form, and then it would release the entire storage volume that's behind the dam through that opening hydraulically. Yeah.
Lake Woodlands Dam, built the same way.
I'm not familiar with the design and construction. Ed,
My understanding is when you look at it, drive over it, they're on Woodlands Parkway, they're not the same design.
The sediment you've got is going the way. Can you analyze that sediment to know if it's actually underneath the dam or it's actually sediment in there? So that hasn't done.
it has not been done.
That makes sense.
Yeah, it's a good question. I suppose we could run grain size analysis and maybe see if it was the aggregate, the drain fill, or and compare it to other materials that we have on site.
Couple of things. What are you actually talking about tubing? You don't know. Is this a full demolish and rebuild properly?
Of the spillway, yes.
Spillway in I think you call it emergency spillway in one area.
Yes.
Auxiliary emergency.
Yes.
So it's replacing, what happened to dam?
New spillway. The dam itself.
Yeah, that's not like-
Yeah.
Modern structure,
That's right.
modern stuff.
Yep.
And there's obviously some cost savings to put the things at the same time. Or
Yeah, absolutely.
phase one and phase two together.
Yeah. Yep.
I think that, one last question then, does the offset of the spillway, if you do, that, other than visually, it's gonna look like a bottle or OCD symptoms to look at dam and that's spillway. Other than that, is there any other operational issues? I think, with that spillway being offset, under dam structure on one side versus another.
Nothing operationally. There might be some permitting limitations where we need to kind of keep our impacts within the footprint of the original construction to avoid going into more stringent Army Corps environmental permitting. So the closer we can keep that to the center, I think what you get into is impacts to construct a new stream or backfilling the stream. And then there's also the bridge down, the bridge. Yeah.
Thank you.
No, I wouldn't expect any impacts on the bridge from that. Gentlemen?
Well,
Thank you.
I'm with one point. So not part of it, but probably for the first time in a long time, I do agree with my right on Frank David. That I think all the muds ought to be involved in this. So I think everyone of us will be impacted if something did fail. But I think something we ought to think about too is from a economic standpoint and if something like Impact Magazine can get a hold of what the recommendations are here. I think it would affect the property values of every one of these homes in this dotted line right here. And I think also if immediate action isn't taken, I think, once this got out, that there is a potential there. I think it will have an economic impact on the property value of these homes there. And just think about what happened if something did fail later on. I mean, besides making the news nationwide, the impact that they have on Woodlands also from an economic standpoint. So I think those are some things maybe we need to take into consideration about the importance of acting on this now and giving the observation.
Joseph? I think you were next.
Yeah.
Coming behind you.
Thank you very much, Jimmy and Jeremy. I appreciate all of the details, especially the 88-page report. And I have a question about it just for clarity because it seems to impact the estimates. On the second bullet in section 1.3, I know it's not off the top of your head, but it's the section that speaks about the North Atlantic vertical datum. Number 88 that specifies here's the conversion between the elevation numbers and the groundwater reduction plan. The GeoSolutions did some, and there's a formula. The formula has an example that appears to be inconsistent or erroneous, and I was hoping that you could clarify which is the true value, whether it's the formula that says NAV 88 equals GRP plus 1.6 feet, or the example which explicates it the exact opposite way. The impact of which is the truth is plus or minus 100 acre feet, which would affect your modeling. And I was hoping that you could specify which is the well, number one, am I seeing an error there in the equation?
I'm going to have to get back to you on reviewing this and interpreting it or giving you an interpretation if that's okay.
We did get your question
Okay.
and it's been passed on.
Okay. Thank you. Yes.
Arthur, did you have a question?
Metro Mud, not being involved directly, really here as a citizen learn. I think the important question that was raised by a number of directors is, should we start to have the discussion at the mud level that a project like this beyond the management agreement that 5 months with the annual budget for maintenance? We are a community and the impact to this dam, this failure, the impact to repair does impact all the muds. I think we should consider starting to talk about contribution of each mud towards this project, whatever the final numbers are, because we are a community. And thank you for the opportunity to be here as a member of the public.
Brad, did you have a question?
Yeah. Great presentation, enjoyed the technical detail and the clarity and transparency. Question on the cost. So sounds like what I'm hearing is that you recommend an alternative 1, 5 million cost estimate shows alternative 2, 5.5 million. Is there any consistency there, or am I just reading it?
Those are construction numbers, and then you still have the other costs to go with it. That's where the 14 million comes in at.
I think the
Option for probable construction costs, 5.5 million. The slides, it shows option 1 is fine.
Yeah, the number that's used in the top line,
Yes.
is 5.5, that was option 2.
Brad, I think we were selecting alternative 2 because of the concern of the environmental component. By needing to stay in the center, basically where it is. So we were going with 5.5. If we could go to alternative 1 with environmental, it would be less. We wouldn't go with alternative 3 because it would be more expensive. The construction would be different. So we kind of went to a middle ground.
It sounds like your experts saying, oh, alternative 1 can't. Right?
I mean,
We have some concerns. If you offset the service spillway to the right of current, how does that align with Kirkendall Center Bridge center line?
Okay, so it's to be determined. So like we're comfortable with the technical recommendation from the experts.
And that recommendation I made just a little bit ago was off the cuff, and I don't recall that we made a recommendation in the report. We presented a lot of data. We presented some pros and cons to help inform the River Authority on making a decision, which is ultimately theirs.
Slide.
Which slide again? I'm sorry.
The back slide shows the yellow slide.
Yes.
So if I understand, this is based upon the 2078 factor, which is much higher than anything we've ever seen in RV or that state like, correct?
Correct.
Okay. And we think we have this model for tax state flood? What I heard?
Tax state flood, LJ.
Yeah, I haven't seen them run a dam failure model on it.
Oh, yeah, okay, I thought that's what you said earlier.
I said Bear Panther drainage project that you've seen was based on the tax state flood.
It wasn't a dam failure.
No, I haven't seen that.
Okay, so this is pretty significant. What I'm concerned about is the messaging that goes with this. What's the likelihood of this happening? And can you give us some probabilities? And should we take immediate action to mitigate this by draining the reservoir? And you've heard from others, what this would impact community. But I'm not sure, is this like it happens once in 1,000 years? Or is this something that we ought to be worried about happening the next time there's a hurricane? So I think we owe it to our citizens to put some context in this. Put this slide around here as a possibility, about putting some probabilities on it. Could lead to some concern that maybe it isn't warranted. But if it is warranted, it's our responsibility to take immediate mitigation steps. So I think we need guidance from you guys on how we proceed.
So the probable maximum flood or probable maximum precipitation, as an industry, we don't assign a annual exceedance probability to them. It's not like you can go to NOAA Atlas 14 and pick off 100-year rainfall or 500-year rainfall. That said, the probability of PMFs are what, Jimmy, on the order of thousands of years? So a pretty extreme event. It doesn't mean it's only going to occur once in 1,000 years. It just means it has a low percentage of occurring in any given year. And it could be an event smaller, much smaller than the PMF that could cause a spillway to jack and a failure. So it's not necessarily the PMF that's the issue. From a compliance standpoint, I mean, the spillway is not structurally sound to pass the design storm, but there's a risk that it could become damaged or fail for a much smaller event. We recommend moving forward with a comprehensive rehabilitation immediately. Draining it, we have not discussed that. Now, I've been involved with other projects in other states where the state dam safety officers are much more aggressive and have dictated draining reservoirs. So, I mean, it's not uncommon. I'm not saying it is or isn't recommended for this project. We just haven't discussed it.
before we go, one thing to keep in mind, that image is not available to the public. That's been our brief analysis. We decided to show you all so you understood the order of magnitude, what could happen if they fail. Just so that you're aware, because I think it will help you in your decision making on whether to move forward. That's up to y'all. But if you weren't aware of this, which you probably weren't because you hadn't asked for that brief analysis, probably didn't know it existed.
Oh, this is an open meeting.
It is an open meeting, but we decided to show this to you so you had some awareness of what is in our brief analysis. Fred?
This was the question I was asking earlier about rural assessment. And I think that's critical. I also think you've done a fine job in explaining what the worst case scenario is. And I think that the next step for the SBRA and for the WWA is to provide us with financial model because bonds, and I wrote this up in my SWB report, the supplemental agreements that we have with the SBRA, in my opinion, are not for the betterment or the best interest of our constituents. And it's all detailed in their by section category. Rather than argue that issue, I suggest picking up the model. I did some quick back of the envelope analyses, and the financial numbers per home, per commercial property, per resident, retail, comes out to a fairly doable number. For an estimate of 16 million, I use a little higher number, only for one reason, to be some flow. I think that's the next step. We heard your report. Other people here have already requested additional information, different analyses. I think the next step would be to take a look at the financial model, because I don't think bonds are in the best interest, given supplemental agreements, in our constituents, and I would stand firm on that. So with that, the vote of you and Ed, you can comment on financial model. It's a service that your company provides.
Not in the terms that you're speaking, right, Jimmy? I mean, like for risk analysis, usually we look at life loss for dam consequences. There could be economic losses that we could look, but ordinarily life loss is what's going to drive dam safety projects, right, Jimmy? Yeah. Welcome.
So this is a really easy one. We've got one tranche of money that we have coming from the franchise. He's earmarked as I understand this for phase one. And then we want to go back and get another tranche of money from him for phase two, like an additional 5 billion. Okay, so Dave Crenshaw right now is got 3 contenders coming up. What if he gets primary next March? And he's out of the picture. Are we out of the picture for $5 million?
Not like this.
Just what happens?
I answer your question. If Congress does what they're supposed to,
Well, that's a big issue.
the assumption is they will pass a budget by December 31st. Yes. And then the money would be in hand maybe after the primary, but then it's not an issue.
Won't matter which candidate wins.
Right,
Correct.
right, that's it, because this is, we're going to ask, and that was my, all right, but if he doesn't get in, and the next person gets in, like, this isn't an issue for me. And we're basing on the fact that we're gonna get the 8 million. I kind of really want the comfort factor that even if Dan's not there, and we got somebody else, that money's still coming.
Right.
Okay. I'm good, just.
John, did you have another question?
I do. Assume we do this project.
Okay.
Okay, I'm not gonna ask an engineer how long it's good for, because I know they won't give me an answer. But I would like to know, if then we do this, do you suspect there may be any other work in the next 5 to 10 years, other parts, other than the ones you fix? Something else that we should worry about is over some dam.
For what SRA is responsible for? No, because that's your biggest capital investment. Now, Eric's working with the 5 MUDs on
Bear Panther, Alden Brand. And working with him to help find funding sources for that. Other questions?
In the
Yes, ma'am.
size of the reservoir be enlarged to kill two birds with one stone and mitigate flooding where we're currently addressing it with Bear Branch project?
My understanding is no, because houses were built at a certain level. And I think remember George Newman? He's asking them about it. And the answer back to him was, no, you can't store more water without it impacting the homes that already exist.
Homes that already exist to the west of the dam?
Yes,
Okay.
both north and south. Yeah,
If this work is completed, what is the service like for the new spillway?
50, 75?
I want to give you a smart answer, but I also want to make some friends here. Ordinarily designed for a 50 or 100-year design life for concrete structures. That said, there's concrete built in ancient Italy that's still running. Yeah.
yes.
Yes. 50 to 100. So it's a legacy project for y'all, and you can
And
be
by building the joints better than what they were originally, with the water stops and the cutoff walls and the drainage systems under the spillway.
reduced maintenance costs.
It does reduce maintenance, but there would be some regular maintenance that would be necessary. Not in the 10 or $14 million range.
Is there any other, like, fixes that you guys looked at, aside from rebuilding the entire dam? Like, is there a way to put pylons straight down it to anchor it in and make it stronger? I don't know what other options are out there. Did you guys look at anything else, or is there?
No, we were focused on replacement. We felt that was the best way. I mean, I showed that slide with all the red lines on the joints, and if we want to do focused joint repairs like what was done previously, just in spot locations, but do that all over, you can see that we would be just making Swiss cheese of the spillway, and probably doing more harm than good doing it that way. Let's see there. No, more than that. They're probably 40 foot. Yeah.
Last chance. Thank you all very much. We appreciate the questions and your attention.
Thanks for